Hello, everyone. This is Will Mitchell with VETRO FiberMap, and welcome to our first ever customer enablement webinar, the first in a series. It is noon Eastern time. I think we have participants joining us from quite a few different time zones. Thank you all very much for making the time for this lunch and learn, as we're calling it. As this is our first go at this exercise, I'm hoping that everyone can hear me okay. And we will proceed with the program. So this again is the VETRO FiberMap Customer Enablement Webinar Series. Thank you very much for making time to join us. My name is Will Mitchell. I'm the VETRO's co-founder and CEO. We're very excited about the growth in our customer base around the US and around the globe and the continuing evolution of our platform. One of our biggest priorities is customer success. It's sort of who we are and how we approach business. We value your business very much, and we like to do whatever we can to enable your success. We want our platform and our software to be easy, intuitive, powerful, and useful to you. And we really want you to like using the software, so we put a lot of time into design and workflow. We value customer feedback and input, and we welcome it, and we encourage it. We strive to be responsive to your issues when they do arise, and we treat you as valued partners. So again, big emphasis here on customer success and customer enablement. These webinars that we're about to embark on, starting with today, will be short and to the point. Each will focus on a single tool or workflow, and we will record them and make them available in our forthcoming customer resources portal that will go live online along with our new website in the new year. With that, I'd like to turn the program over to our customer success point person, Stephen Marchessault, who will run the show and take you through this first webinar series.
Thank you, Will. Like Will said, I'm Stephen Marchessault. I'm the customer success specialist here at VETRO FiberMap. Just a couple of housekeeping things about the Zoom webinars. Please feel free to use the Q&A functionality of the Zoom webinar. If you open the application, you should have an icon to open Q&A, and you can submit questions there. We have a team of VETRO panelists available to answer those questions for you. If you don't receive a reply straight away, we may set your question aside and get to it at the end. At the very least, we will be sure to get back to you in any case. So before we start to dive into some of the content and the overview of what we're doing, I would like to start out with a poll. So we're using Zoom poll feature that I'm now sending to everyone, and this is an anonymous attendee poll, just generating some data around the industry that is represented today. So if you would indicate the choice of industry and submit your poll, we'll have those results in, and we can share those with everyone in just a moment. All right, we are up to 75%. Any last voters? Go ahead and make your final choices now and submit. And so now here we can share the results. And our largest representation is from ISPs. We also have a lot of WISPs here, but it looks like we have a representation across all industries. That's great. Thank you for sharing that. We are just getting rid of some, there we are. All right. So a quick overview of what we're covering today. We're talking about drawing, validating, and building in VETRO FiberMap. The first topic that we are getting into is drawing. And what we're especially interested in covering is just the network features of VETRO. The points and the cables that exist in VETRO FiberMap. We also have non-network features, so we call them. That includes poles, and conduits, which are very important. They're the supporting cast, the things that the fiber hangs on, runs in. We can also display overlays and other reference data, but all of that will be a different session topic. So for today, we're just going to hone in on some of the drawing tools and methods for the primary VETRO network features, the points and the cables. So then after that, we'll get into the validation process. We validate what we've drawn. This is an automatic process that is performed alongside with the build, but you can separate this process and run it manually. So this runs a validation of the network geometry and the feature attributes. This is an important step, and we'll get into how and why it's important. And lastly, we'll talk about the build. And the build is a very important step that all network engineers and designers need to understand. It is something that is, when you run it, the automatic validation kicks off, and the validation will ensure the integrity of the network so that you can do reservations, build circuits, and it checks in with some engineering-based rules, some of which are obvious, the physical world and how you would want your network to be built. It creates a trace and aligns the geometry for the network. And then it breaks the cable at network points for splicing, splits the cables at junctions, and establishes pass-through in certain situations. Those last 3 points, we'll get into some examples and a demonstration of that. This is a very important understanding to have when you run the build. So I'm going to pause my screen for a moment while I jump over to VETRO FiberMap and resume here, and we should be just fine. All right. So here we are, the main screen of VETRO FiberMap. When you first log in, this is the screen that you see. We don't have any of the tools enabled. We are in read-only mode. So the way that we organize the instances of VETRO FiberMap around projects and plans. So a project typically represents a geographic region, whereas a plan, which exists within the project, will represent either a subset, a smaller geographic region, or it can represent phases of that project. So some of the ways that we navigate this map, we can click and drag to move around. We can use a scroll button on a mouse to zoom in or zoom out. You can double click to zoom, shift double click to zoom out. We also have these tools over here for zooming in and out. We are currently displaying as a base map, Google Base Maps. So right now we're looking at a hybrid of the road and the satellite view. The road view can be useful when you want contrast with your icons and you're planning just with the roads, but then you might switch to the satellite view when you are ready to locate service locations, for example, or poles. So in order to begin editing, we need to enable the global editing mode, this icon right here. So once we select this, we'll see that our toolbar appears. So these are the fundamental tools of drawing in VETRO FiberMap. We have the points, the lines, polygons, and our toolbox. So I'm going to create a new project, and we'll call this webinar. And within that project, I'll create a plan. And so I'm going to demonstrate different phases. And we'll get into projects and plans in later sessions in phase management. We can change the phases here, but here's where we manage the plans that we want to view. And then this important step, when we're ready to edit a plan, we need to select the pencil icon. And so now we're able to begin working with this plan. So the first thing we'll do is to draw a point. So we'll select this tool icon here. And the first thing that we do when we draw a point is we indicate the type. So most networks start with what's referred to as a point of presence or a head end or a central office or a CO. So I'll start with that here. And so now we have the opportunity to enter some attributes. We can assign materials. We can attach equipment like a patch panel. And then once we have all of our attributes filled in, including required fields, like the number of ports for the patch panel, then we can click anywhere to draw. So the corner of this cornfield in Iowa looks like a really great place to draw our fictional CO. Now we're going to check in with the attributes or edit the attributes at that point, and we need to stop using this tool. We can either hit escape or we can click on that point manually. Now we can select the point, see the attributes, make edits, so on. So now I'm going to continue to build out this network using fiber access terminals. So here we have fiber access terminals, and say I want to attach a splitter, and I'll enter the splitter configuration, say a 1x4, and we can attach multiple splitters, but we'll do just one for now. And we can assign materials and fill in attribute fields. And rather than going through all of those steps every time, drawing and then saving, we can fill in the attributes that we want to retain and use this feature to autosave. And now we can jump onto our map and we can click to add points, however many as we need, retaining those attributes, and so on. And then the last step will be done. And so now I've added a fiber access terminal with splitters and the attributes that I filled out. Looking at these FATs, we see an ID has been automatically generated by the system here. And as we click through these, we see that that ID has incremented by 10. Now, it's possible for a user to come in and manually set the ID for these, but this ID can be very useful for identifying this FAT in your reporting, and you can also perform a search here to locate that FAT. So the recommendation is to keep those system-generated IDs in place because it retains the unique nature of each. So now we'll jump into drawing lines. So to draw the lines, I'll select the line tool. And the first thing I want to draw is a backbone. So we have a fiber capacity, which is a required field. And we're going to draw from our CO to our first FAT. So to draw, we begin by clicking. And now we can move our mouse, whatever direction we need the line to go, and we click to establish a vertex. And then we can click again to establish another vertex, and so on. And I can proceed in this manner, clicking and tracing until I get to my FAT here. And so a network point will cause the cable to snap to, so we can click there and click one more time to finalize our drawing. And then we'll save. Now I want to draw laterals connecting the rest of these FATs. And we're making sort of a large network, but this will be good for demonstrating some of the scenarios that we want to illustrate for the build. So again, we have the fiber capacity, and we'll set that. And as we build, as we click, we can choose to proceed directly through these points and save. And we can also use the autosave feature with lines to draw multiple line segments, each with unique IDs. And this will be important for the build. So I'm going to draw this line, click again, and I don't need to save. It will just automatically, if I have this setting selected, it will automatically draw. And again, excellent. So now, again, I hit escape to leave the lateral line tool. And so now I'm able to jump into each of these lines and see some of the attributes. So when we look at one of our cables, one of the attributes is the length that we drew in two-dimensional space. And this link this length will be affected by the helix factor and the sag factor, and a calculation will display here for the total length. You can edit the helix factor or the sag factor for a cable if you open the edit cable feature here in the toolbox, or you can head to the dashboard, units and measurement, and you can set those factors here. The other thing that factors into these calculations is slack loops. You can add a slack loop to a line. And so if we indicate that we have 25 additional feet, and then we place that on our line here, and then save. When we open this line, this final calculation will be the sag factor, the helix factor, plus that slack loop, which has been added. There's also an attribute within drops to service locations, which is the premise length, and that will add as well. So one more feature to show you when you're drawing that will allow you to set a length for a line is if you are drawing the line and you right click, you can manually set the length. And so say I want this to be 350 feet and then enter. This snaps to 350 feet. So we know based on readings from the field, say measurements taken, that this is the length we want this line to be. And click. I'll bring this over here and click. We'll make it 100 feet and click again. And that's how you set the length for that line. So now we see we have a break here, and this is intentional. I'm going to leave that way as we get into our validate. Before I do, there are just a couple more features I want to jump into really quick. It's possible to move a feature. So in order to move a feature, you simply select the feature here, and you can click and move around as needed. You can also use update coincident cables. So now if I move this point around, the cable moves with it. And then save to retain those changes. Working with lines that are already drawn is a little more interesting. So there are a few more options. If we select a line, we have endpoints. So if I select any one of these endpoints on the left or the right and click once, I can now begin to trace from that endpoint. And I can click again to finalize, and I can hit save, or I can cancel to revert back to the previous changes. Going back into the line, each of these vertices can be clicked and dragged to create tracing. And then if you click on an intermediate vertex, it creates these other intermediate vertices, which you can then use to do some more minute tracing as you zoom in. But again, I'll cancel that and keep this running parallel to our cornfield. And then the last edit that you can make as you're drawing is to double click on a vertex, and it will remove the vertex and snap back to the nearest vertices. You can cancel that. Or when you're drawing, if at any point you draw an incorrect segment, you can use Command Z or Control Z to undo the previous, and it will revert back. So that is kind of the quick overview of the drawing tools that I wanted to show you for today. Now we need to get into the validating. So the validation of the network geometry is, again, something that occurs automatically during the build process, but you can do this manually. So this is a checklist of rules and requirements before the build can be performed, and to ensure that you've created a network that makes sense from the engineering rules perspective. So to do the validation, we open our toolbox and select Validate Current Plan. And we're presented with this box here. So our attributes all check out. We have green check marks. All of these requirements have been fulfilled. but it looks like we have something that hasn't been fulfilled in the network. So if we expand here, we can see that this rule about laterals, that it should be connected to 2 points, has not been fulfilled. So we can expand using the plus icon, and this link will bring us right to the erroneous cable, which we know was not connected here. So we'll click and drag that over and save. We also have a material validation when you're attaching materials to your points into your equipment, and that'll be part of a different session, but that does exist here, and it's a similar format. It does an automated checklist to make sure you attach materials to everything. Okay, so we're going to talk next about the build. Before we do, I want to jump back into the slides and talk about a couple of scenarios involved with the build. And so just a reminder that the build is a process that you kick off. It makes sure that your engineering-based rules have been fulfilled. It does some tracing in the background and make sure that we have the proper geometry for what we're trying to do. But it also performs these breaks and establishes pass-throughs and splits the cable at junctions. So the breaks and the pass-throughs arise in a couple of different scenarios, and the scenarios are all determined by how the lines were drawn and the workflow that was followed. So we'll jump into that with the slides here. The first is scenario number 1. The build process will create a pass-through. So if you have a point like we have here where the incoming cables both share the same ID, and the way that this is caused is if we have a continuous cable that we draw through a point, or if we have a cable that was already drawn and we placed a point on the cable, and then we run the build, and we look at the splice diagram for that point, we'll see dotted lines. The dotted lines represent the pass-through. And these pass-through lines can be cut, and I'll show you that, and then they can be used for splicing or attaching equipment. The second scenario is that the cables do not share the same ID. And so this situation would arise when you have a point drawn and you draw cables, 2 separate cables to that point, terminate them and save them, then run the build process. And if you open your point, you'll see that the cables are cut and they're available for splicing. They've not been configured as a pass-through. And then the third scenario is an option that exists within the attributes for the cable or for the point. So within the cable, you can check this option to allow this fiber cable to pass through network points, or in the point, it's allow fiber cables to pass through this network point. And when you run the build process for a continuous cable, you will see within that point an empty splice diagram. There are no splices available. So this might be a situation where you have a cabinet where you're doing splicing with lateral to neighborhoods, but you want a backbone trunk to pass through that same cabinet, but you have no intention of doing any splicing there. So you want it to be represented just as a pass-through that can't be cut. So these are the 3 scenarios. So now we'll jump back into VETRO to see what this looks like. So here. So the first thing that I want to do, we have all of the scenarios represented here, and we'll review those again. But first I want to quickly add a junction or 2 junctions to our backbone. And the junction can be used to represent a situation where the cable goes from aerial to underground. And the important thing to understand in VETRO is that when we run the build process, this cable will be split at the junction, or better yet, yeah, that's fine. So I'll draw those there. So the cable will be split at that junction. So now we are going to run the build. So here's our option to build the current plan. It's performing the validation, and then we get this notification that the network has been built. Everything was successful. So going back to our junction example, we now see that this backbone has been separated into 3 different cables, each with the same ID. backbone 50. So here, I can establish that my placement and the attributes for this backbone to the west of the junction is aerial. And then here, for a brief section, it goes underground. And then here, we can establish as aerial again and save. And you need to remember whenever changing attributes to save. And we have styling that we've set for these, and this is all customizable to reflect when it's underground, it will be a dotted line. So this will be aerial and save. So here we see our backbone goes from aerial to underground back to aerial again. Now looking at some of these other examples, we have an FAT here with a cable to the left and a cable to the right that have different IDs. So this is lateral 150, this is lateral 140. So if we open our FAT here and open the splice diagram, we have cut cables because the left and the right have different IDs. We also have a situation where we have a lateral 130 and a lateral 130. They are the same ID. So within this point here, if we open the splice diagram, we see when we're looking at lateral 130 going west, the pink cable, and going north, the cyan cable, they have been established as a pass-through. This pass-through, of course, can be cut, and we can now attach a splitter here if needed, and we can cut this one here and splice cables. We'll say attach to port 1 of the splitter and so on. So you can work with the pass-through, but that's its default position. And then lastly, if we add an FAT to this cable here and save, and within this cable, we check this box to allow this fiber cable to pass through network points. So we don't want to do any splicing in this mid-span FAT. If I run the build process again and open this FAT, we see here an empty splice diagram. There is no splicing available for this cable. And we could bring in other cables with that checkbox unchecked, and then we would be able to perform splices on that cable after doing the build, but not this one with the checkbox. So that concludes the demo portion. We'll go back to the slides to just review some helpful hints and reminders, some of the things that we covered in this session. So when you have a point or line tool selected, just a reminder, you can hit escape or select the tool again to disable the currently selected tool. This allows you to select other points and view and edit their attributes. If you use the autosave VETRO parts with the same attributes to draw multiple points, or cables with the same attributes or equipment attachments, it's a quick way to automate the creation of many points that all have the same attributes. When you're drawing, you can use Control-Z to undo the last drawn cable segment. When you have a drawn cable, if you click once on the end point, and you can continue drawing. Looking more at cables, with the cables, if you click on an intermediate point between cable vertices to create more intermediate vertices, you can then click and drag those around to create minute shaping. You can shift and click to select multiple features of the same type. You can shift, click, and drag a box around features when using the Move Copy Features tool. And you can place a junction on a cable and run the build to split the cable. And this is most commonly used, as we showed, for transitioning a cable from aerial to underground. So that concludes this webinar session for drawing, validating, and building. In the future, we plan to do a lot more of these sessions, similar sessions, where we get into a topic and try to cover some of the frequently asked questions and make sure that we're helping our users really understand what's going on with a certain feature set. So our next session will be the 9th of January, and we will be covering circuits. We have some other topics listed here, some of which I mentioned today, and we'll be sending out invites soon. Of course, we're available by phone or email, or you can connect with us on LinkedIn, Facebook, or Twitter. So please reach out. Our technical support team is available by phone call Monday through Friday, 8 to 5 Eastern Time, and we're very responsive with emails, and we're happy to help. So now we'll jump right into some question and answer.
Thank you, Stephen. This is Will. We also have Alex Cavagnaro on the line on our support team. If anyone has questions, please feel free to introduce them in the Q&A feature in the Zoom webinar. We've had a couple of questions come in on various topics that we can respond to offline after the webinar is over. If you have anything around validate, build, and drawing or digitizing, please feel free to ask. One question that came in, I think we could jump back and quickly run through a rather common scenario, which would be to insert a splice point or a splice closure into an existing cable and then build that cable and see how it impacts or cuts the cable into two parts.
Sure. Get back into FiberMap here. And Zoom. So here we have our example that we were working with. So we'll look at the backbone here as an example. So we are going to add a splice closure, we'll say, to the backbone. So the backbone has been established, it's already been built, and we're clicking to add this point here, and we'll save. Now, the key is the default setting for the splice closure, or for any point, is that this allows fiber cables to pass through the network point. This is unchecked by default. And likewise, in the cable, this is unchecked by default. So in the other situation I showed you, I checked this for the cable, and splicing was not available for the point. But neither of those are checked, so I'll run the build process. And if we have a look at our splice closure here, what we'll see is a pass-through has been established. Now, going back to the rules, the circumstances that give rise to the creation of a pass-through, the key here is the ID. The ID for this backbone to the left, this backbone to the right is the same. So now that we've done this build, the lines are split there, but they have the same ID. So if I were to change this to 52 and then hit save and then run the build again, we now have cables with different IDs to the left and the right. And if I open the splice closure after running the build, we will see that those lines are cut. And a pass-through was not established because the IDs are different. So we can now jump back into this east-going backbone, change this back to the original ID so that these IDs match on the left and the right. And if we run the build and open our splice closure, we'll see that it has been established as a pass-through.
Thank you, Stephen. So, a typical scenario here is you're cutting into an existing cable with a splice situation, and you could then ring cut out some strands and splice them out to a new cable coming in from the north or south, for example, or drop to that house or what have you. Thank you, Stephen.
So we have a question that came in. Someone was wondering, will it be possible to have these slides sent out? What about the recording? We are currently recording this session, and it's our intention to host this on our customer help portal, which is coming soon. And we'll also send out a follow-up email inviting anyone that would like a copy of the recording for today's session to just get in touch with us, and we can send that to you before the help center is in place. Well, if there are no other questions, that concludes our webinar. So from everyone here at VETRO FiberMap, thank you for joining. We look forward to hearing from you and continuing to work together to make the VETRO FiberMap the best fiber design and management tool available.
Thank you, everybody, and we wish you all the best and happy holidays. Hopefully everyone has a little R&R time ahead with friends and family, and we will see you again at the next webinar, or feel free to contact us in the meantime with additional questions or support needs. Thank you very much.